Hello guys, greetings to everyone. We have been given the following questions to answer them. Question 1 says evaluate. Question 1, evaluate in the brackets we have these two mixed fractions to add them. We have to multiply the result by 10. Divided by 2 and 1, 7. For us to easily answer this question, we are going to make good use of BODMAS. We are going to make use of BODMAS. We start with B, which is for brackets, O, which is for off. The off in this case simply means power of, square root of. In some books you hear of order, which might be powers, indices, or roots. So B stands for brackets, O for off, O, order, D for division, M for multiplication, A for addition, and lastly S for subtraction. So the first thing we have to start by simplifying what we have in the bracket. So if we take the mixed fractions we have in the bracket, 2 and 5 over 6 plus 5 and 1/3, we have to add these two fractions. For us to add these two fractions, the first step, we need to start by adding the whole number parts of the fractions. So 2 plus 5 gives us 7. We are going to write 7 as such. Then we draw our vernaculum. This is the line that separates the numerator and the denominator of a fraction. Next, we need to find the LCM of 6 and 3. We know 3 is a factor of 6. 3 times 2 gives us 6. Therefore, the LCM of 3 and 6 is simply equal to 6. So, at the denominator, I'll write down 6. Next, I will take 6 divided by 6 gives us 1. 1 times 5 remains 5. The operation sign is plus. I'll write down plus. 6 divided by 3 gives us 2. 2 times 1 remains 2. Next, this will give us 7. 5 plus 2 gives us 7 all over 6. Next step, what we have to do is, this is an improper fraction. You can see the numerator 7 is greater than the denominator 6, of which for a mixed fraction we have the whole number part and a proper fractional part. When we talk of a proper fraction, it is a fraction which has a smaller numerator and a bigger denominator. In this case, we know the fraction 7 over 6. Writing it as a mixed fraction will give us 7 divided by 6. The whole number part is 1. Remainder 1. The remainder is 1. So the 1, which is the remainder, is to be divided by 6. So this is the fraction 7 over 6 as a mixed fraction. This will simply give us, we know the whole number part is 1. We are going to add 7 plus 1. We are going to add 7 plus 1. Then to it we attach the proper fractional part. You can see the numerator is less than the denominator. This will give us 7 plus 1 gives us 8 and 1/6. Next step, We are going to copy down the question. 10 times plus 5 and 1/3 minus 2 and 1/3 times 3 over 7 divided by 2 and 1/7. This will simply be equal to, we are going to replace all what we have in brackets here with 8 and 1/6. So this will give us 10 times, remember these brackets are for multiplication, times 8 and 1/6 minus 2 and 1/3 times 3 over 7 divided by 2 and 1/7 as such. Next step, we are going to convert all the mixed fractions to improper fractions. So this will simply be equal to 10. We can write 10 as 10 over 1 times, we need to convert this mixed fraction to an improper fraction. 6 times 8 gives us 48 plus 1, 49 over 6 minus 3 times 2 gives us 6 plus 1, 7 over 3 times 3 over 7 divided by 7 times 2 gives us 14 plus 1, 15 over 7. Next, we know from BODMAS we are already done with the brackets. There is no root or hours or indices that we have to simplify. So we move now to the next operation, which is D for division. So we are going to perform the division first. This will give us 10 over 1 times 49 over 6 minus 7 over 3 times 3 over 7. We have to divide these two fractions, 3 over 7 by 15 over 7. So dividing those two fractions, we are going to maintain the first fraction, 3 over 7. We change the division sign to multiplication. Then we invert the last fraction. 7 goes up, 15 comes down. Next step, we are to simplify. Before we carry out multiplication, let's simplify. We know 2 will go here, 5 times 2 will go here 3 times. So this will give us 5. We have to multiply these two fractions. So 5 times 49 will give us the numerator over 1 times 3 will give us the denominator minus. We have to simplify these fractions here. So we multiply 3 will cancel 3, 7 will cancel 7. Right? Next, so this will simply give us 1 minus 1 times 1 times 7 all over 1 times 1 times 15 as such. Next, this will simply be equal to, if we take 49 times 5, 5 times 9 will give us 45. We are going to write 5, we carry 4. 5 times 4 will give us 20 plus 4. So this will give us 245 all over 1 times 3 gives us 3 minus 1 times 1 times 7, 7 all over 1 times 1 times 15, 15. Next, we have to perform the last operation, which is subtraction. There is no addition. We already done with multiplication, so we go now to subtraction. Next, we have to find the LCM of 3 and 15. You know, 3 times 5 gives us 15. 3 is a factor of 15. Therefore, the LCM of 3 and 15 is simply equal to 15. So we are going to write down 15 here. 15 divided by 3 gives us 5. 5 times 245. 5 times 5 gives us 25. We are going to write down 5. We carry 2. 5 times 4 gives us 20. Plus the 2 we carry 22. We write down 2. We carry 2. 5 times 2 gives us 10. Plus the 2 we carry 12. We write down the 12. So this will simply give us 1225 minus 15 divided by 15 gives us 1. 1 times 7 gives us 7. Next, we add to subtract. 1225 minus 7 will simply give us 1218 all over 15. You'll see that this is an improper fraction. The numerator is bigger than the denominator. So we need to express it as a mixed fraction. If we divide 1218 by 15, we know if we take 30 times 4, it gives us 120. If we take 30 divided by 15, it gives us 2. So if we take 4 times 2, it gives us 8. Next, if we take 1 and 2, we are going to form the number 12. 12 is less than 15, so we need to attach 1 to it to form the number 121. 121 divided by 15 will give us 8, remainder 1. But we are not interested in the remainder, so we are going to write down just the whole number part, which is 8. 8 times 15 gives us 120. We subtract 121 minus 120 gives us 1. We bring down this 8 to form the number 18. 18 divided by 15 gives us 1. 1 times 15, 15. If we subtract 18 minus 15 gives us 3. So 3 is simply the remainder. 3 is less than 15. So the whole number part will simply be 81. And the fractional part, the proper fractional part will simply be 3 all over 15. Next, 3 over 15 can be further simplified since 3 is a factor of 15. 3 will go to 3 one time, 3 will go into 15 5 times. So this will give us 81 and 1/5. This is our answer. We are going to underline the answer. Next, we go to the next question. Question 2, which says the sum of two numbers is 8 and their difference is 2. Find the two numbers. For us to answer this question first, we are going to start by saying let the two numbers be, take any letter, you take any letter of your choice. As for me, I'll take the two letters to be A and B. So we let the two numbers to be A and B. If the two numbers are A and B, we have been told that the sum of the two numbers gives us, so we add A plus B is equal to A. We are going to call this equation 1. And we have been told the difference of the two numbers, A minus B, gives us 2. So we call this one equation 2. The difference simply means when you subtract the smaller number from the bigger number, you obtain 2. I know some of you will be wondering why I took A minus B, why I do not take B minus A. If you take B minus A, you still end up having the same results for the two numbers. So there's no problem. So these are the two equations. Next, these pair of equations we have here, we call them simultaneous linear equations. They are linear because you can see the highest power of the variable A is 1. The highest power of the variable B is 1. So we can solve this pair of equations by making use of substitution method, elimination method, the matrix method, or graphical method. So I would prefer we make use of the method of elimination. We are making use of the method of elimination because it is very fast and easy to carry out. You can see the coefficient of A is 1, coefficient of A in the second equation is 1, coefficient of B in the first equation is 1, coefficient of B in the second equation is -1. So if we add these two equations, the variable B will disappear. If we subtract the two equations, the variable A will disappear and we can look for B. Next, we are going to say adding the two equations, adding the two equations, So let's add the two equations. We have A plus B is equal to 8. A minus B is equal to 2. So we have to add these two equations. We are going to put a plus sign here in front. Then we draw our line, this horizontal line. A plus A plus A gives us 2A. B plus negative B plus negative B is simply equal to B. We know positive, negative will stay. So this will give us B minus B, and B minus B is 0. B has been eliminated. So this will simply be equal to 8 plus 2. 8 plus 2 gives us 10. So we have 2A is equal to 10. For us to get A, we are going to divide both sides by the coefficient of A. And the coefficient of A is 2, the number we see in front of the variable A. So 2A divided by 2 is equal to 10 divided by 2. 2 will cancel 2. This will give us A to be 10 divided by 2, which is 10 divided by 5. No, 10 divided by 2, not 5. We are dividing both sides by 2. This is 2. So 10 divided by 2 gives us 5. So this is the value of A. Next, after finding the value of A, we need now to get the value of B. For us to get the value of B, we are going to put in the value of A. We know A is equal to 5. Putting the value of A equal to 5 into any of the equations of our choice, into equation 1. Let's take equation 1. That is, so in equation 1, anywhere we see A, we are going to replace A with 5. So this will give us 5 plus B is equal to 8. Next step, we need to make B the social formula by transferring 5 to the right hand side. This will give us B to be equal to 8. When 5 crosses the equal to sign, it becomes negative. This will give us B to be equal to 8 minus 5. 8 minus 5 gives us 3. So that's the value of B. Next, we are going to conclude, therefore, A is equal to 5 and B is equal to 3. So these are the values. We underline them. Yeah, our answers. So we can verify to see if these values if the two values are true. Therefore, a equal to 5 and b equal to 3. We can verify to see if we take a plus b, the sum of the two numbers should be equal to 8. So 5, I'll replace a with 5 plus 3. 5 plus 3 gives us 8. True. Next, we need to find the difference. A minus b, the difference of the two numbers should give us 2. 2, these two. So 5 minus 3 gives us 2, which is true. So the two values are correct. We are done with that question. Next, we go to question 3. Question 3, we have been given the matrix, given that the matrix M is equal to 1, 2. For the first row, this is a row. 1 minus x. X for the second row. This is the second row. This is the first column. This is the second column. Take note of the difference between a row and a column. Question A says we should find the transpose of the matrix M. The transpose of the matrix M is denoted as M to the power capital T as such. We read it as M transpose. If we have the matrix M to be equal to A, B, C, D, then M transpose is simply equal to, we are going to take the first column to form the first row. It gives us AC. Then the second row, we are going to take the second column to form the second row, BD. That's all what we do. Next, let's go back to our question. M transpose will simply be the first row the first column becomes the first row, 1 minus x. The second column becomes the second row, 2x. So this is all about M transpose. We are done. Underline the answer. Next, we need to go to question B, which says find the value of x. This value, not values. I think there's no s here. Find the value of x for which M is equal to M transpose. M, we know M is a matrix 1 minus x, 2x. It is equal to M transpose. We know M transpose is this matrix 1, 2, 1 minus x. Then here we have x. Next, we are going to make use of equality of matrices. If we have, for example, two matrices which are equal, A, B, C, D, is equal to E, F, G, H. If these two matrices are equal, then A must be equal to E. They are the same positions. B must be equal to F. They are the same positions. C must be equal to G. And lastly, D must be equal to H. We are going to apply equality of matrices here. So by equality of matrices, matrices is the plural of matrix. We have 1 is equal to 1, which is true. 2 is equal to 1 minus x, which is true. 1 minus x is equal to 2, which is true. You can see this and this, they are the same. So it proves that it's true. If we had, for example, 1 minus x equal to 3, then you know there's something wrong. Next, and x is equal to x, which is true. We are interested in finding the value of x. We know this 1 equal to 1 is not helpful. 1 equal to 1 is true. It is not helpful for us to find the value of x. X is equal to x is not still helpful for us to find the value of x. 2 equal to 1 minus x or 1 minus x equal to 2 is helpful for us to find the value of x. We are going to take this is a linear equation. 1 minus x is equal to 2. Then 1 minus x is equal to 2. Then for us to get the value of x, we are going to make x the subject of formula. So we are going to keep negative x here at the left hand side. Then we transfer 1 to the right hand side, which becomes negative. So this will give us negative x is equal to 2 minus 1. Next, let's continue. This will give us then negative x is equal to 2 minus 1. 2 minus 1 gives us 1. Next step, we are going to divide all through by the coefficient of x. The coefficient of x is negative 1. Remember, negative x is the same as negative 1 times x. So the coefficient of x is negative 1. This is it, negative 1. So we are going to divide all through by the coefficient of x, which is negative 1, to make x positive. Negative x divided by negative 1 is simply equal to 1 divided by negative 1. Remember, when we divide two negative numbers, the resulting sign will be positive. And when we divide a positive number by a negative number, the resulting sign will be negative. So this will give us, this will become positive. X over 1, if you divide x by 1, it remains x. It will simply be equal to a positive number divided by a negative number. The resulting sign will be negative. 1 divided by 1 gives us 1. So x will simply be equal to negative 1. That's the value of x. Take note of that value. Then the next part of the question says, using the value of x in B above, find the matrix M squared. So we can conclude here. Therefore, it's good to conclude. Therefore, x is equal to negative 1. Take note. Next, let's go to the last part of this. C. We have to find M squared. First, we know the matrix M will simply be equal to M. Anywhere I see x, I'll replace x with negative 1. So this will give us 1, 2, 1 minus negative 1. Then here we have a negative 1. This will simply be equal to 1, 2. We know 1 minus negative 1. The two negative signs become positive. So 1 plus 1, which is simply 2. 1 plus 1 gives us 2. And next, negative 1 stays here. This is the matrix we are going to obtain for M. Now we can proceed to find the matrix M squared. M squared is simply equal to, we simply take the matrix M times the matrix M. Note, if you have, for example, the matrix M as A, B, C, D, the matrix M squared is not equal to A squared, B squared, C squared, D squared. If you have something like this, it is wrong. Instead, the matrix M squared is simply equal to A, B, C, D times A, B, CG times the matrix. So you multiply these two matrices, you get the matrix M squared. So this will simply be equal to, I'll replace the matrix M is 1, 2, 2, negative 1 times, this dot is for multiplication, 1, 2, 2, negative 1. Next, we are to multiply the two matrices. First, we need to know the order of the resulting matrix, the matrix M squared. We know the first matrix M, the matrix M is of order. It has two rows by two columns. So it is a 2 by 2 matrix. So the order of the resulting matrix we have to multiply a 2 by 2 matrix by 2 by 2 matrix. We are multiplying a 2 by 2 matrix by 2 by 2 matrix. So the order of the resulting matrix, we are simply going to throw off the number of columns of the first matrix and the number of rows of the second matrix, because for us to multiply two matrices, the number of columns of the first matrix, must be equal to the number of rows of the second matrix. So the order of the resulting matrix will simply be 2. We're going to take this 2 by this other 2. So the matrix M squared will be 2 by 2. It has 2 rows, 2 columns. Next, we can proceed with the multiplication. We are going to take the first row of the first matrix, we multiply by the first column of the second matrix to get the first entry. 1 times 1 gives us 1, plus 2 times 2, which is 4. Gives us the first entry of the first row. Next, we need now to get the second entry of the first row. We are going to take the first row of the first matrix, we multiply by the second column of the second matrix. 1 times 2 gives us 2, plus 2 times negative 1, which is negative 2. When you multiply 2 by negative 1, remember when you multiply a positive number by a negative number, the resulting sign will be negative. So this will give us negative. Then you take 2 times 1, 2. The answer will be negative 2. Next, we need now to get the first entry of the second row. We are going to take the second row of the first matrix, we multiply by the first column of the first matrix. 2 times 1 gives us 2, plus negative 1 times 2 gives us negative 2. Next, we need to get the second entry of the second row. We are going to take the second row of the first matrix, we multiply by the second column of the second matrix. 2 times 2 gives us 4, plus negative 1 times negative 1. When we multiply two negative numbers, the resulting sign will be positive. So negative 1 times negative 1 will give us 1. Then the next step, we are to simplify. Simplifying this will give us 1 plus 4. 1 plus 4 gives us 5. 2 plus negative 2. 2 plus negative 2 is the same as 2 minus 2, which is 0. 2 minus 2 gives us 0. 2 minus 2 gives us 0. 4 plus 1 gives us 5. This is the matrix M squared. For this matrix M squared, we can decide to factor out the constant. You can see we can factor out 5. You can decide to write out this matrix as 5. You write out the constant 5 times the matrix 1, 0, 0, 1. We know if we take 5 times 1, 5 times 1 gives us 5. 5 times 0, 0. 5 times 0, 0. 5 times 1, 5. And this matrix we have, the matrix 1, 0, 0, 1, is known as the unit is known as the identity matrix for multiplication for 2 by 2 matrices. So this will be our matrix m squared. And we are done with the solutions. In case there are any questions, you leave your questions at the comment section. Do well to like the video and to subscribe to this channel. Thank you very much for watching.